Hello, good afternoon to all of you. I hope all of you are doing well. So, in today's class, we are going to discuss the basic concepts of object oriented programming. Now, in order to understand object oriented programming paradigm, one has to have a very good grip on the following object oriented concepts. The concepts are objects, classes, data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, and message passing. Now, let us begin with a very simple concept that is called as an object. Now, an object is a representation of real world entity in the real world into logical objects in the logical world or object oriented system. Again, I'll repeat it. Just see, an object is a representation of real world entity in the real world to logical objects in the logical world or the object-oriented system. Now, it may be difficult for you to understand. Let us try to elaborate it with the help of an example. Now, let us consider a student management system. Now, in a student management system, let us consider a scenario. So, a student enrolls into a course. A course has n number of semesters. In each semester, there are n number of subjects, and each subject is being taught in a class by a particular teacher. Now, if you consider this particular scenario, I can see that the scenario is being realized as a collection of collaborating objects, where the objects are students, course, semester, subjects, classroom, and teacher. Right, so here what we are doing is just see the objects in the real world are being interpreted as logical object in the logical world or object oriented system. So an object is can be a representation for a person or a place or a bank account or a table or any item that the program has to handle. Now in case of object oriented system, the problem is always analyzed in terms of interacting objects, right? So you need to remember that in case of object-oriented paradigm, the problem is always analyzed in terms of interacting objects and the nature of communication between them. So the nature of the communication between them is through message passing. So two objects interact with each other by passing messages. Now, one important thing that you need to ensure is that whenever you are modeling a system using object-oriented approach, there has to be a close resemblance between the program objects and the real world objects. So close resemblance between program objects and real world object, that basically implies there has to be a complete compliance between what is being interpreted in the logical world and what is present in the physical world. So, for an example, a student in the real world should be represented in terms of student in the logical world. Now, why this is essential is that because if there is a compliance between the real world object and the logical world object, what we can do is we can easily identify the set of associated attributes. We can easily identify the set of associated behaviors. We can easily identify the set of associated relationships, because the attributes of the object in the real world will be the attributes of the object in the logical world. The methods of the object in the real world will be the methods of the object in the logical world, and the relationship between objects in the real world will be the relation between the objects in the logical world. So just see, that is the reason why what we need to have is we need to have a complete compliance between the real world object and the logical object. Now objects, they interact with each other by passing messages. So they pass message to one another and get the behavior exhibited by the object. So object sends a message to the receiver object. The receiver object decodes the message, identify what it should be done, performs the operation, and responds to the sender object. Now each object contains or has data and code that manipulates data. So with each object, there is a data defined and a code defined that works on the values of the data. Now, when objects interact with each other, they interact with each other in a manner that they do not have information about the way how the other object is being implemented, or implemented, or the way how the data is being stored and the code is being implemented. So here, what we need not have is, we need not have the detailed description about the way how the objects are implemented. Now, this is one of the essential features of object-oriented paradigm. So here, what we are doing is we are making objects interact with each other by passing messages where objects need not know the way how the other objects are being implemented. Okay, so as we have already said, in case of object-oriented programming, the objects interact by passing messages where the sender object sends a message to the receiver object. The receiver object receives the message, decodes the message, and finds out what is the operation that is performed, using what data it performs the operation, and responds back to the sender object. Now let us try to understand another concept in case of object-oriented programming, that's called as a class. Now, class defines the object in a very simple term. Class defines the object because so a class, because the class is a mechanism for packaging the data and methods that belong to an object, right, into a user defined data type. So we can say that a class is a user defined data type that is used to define an object, and further it's used to create object. Okay, so that's why it said that objects are variable of type class. Objects are variable of type class, or objects are instance of a particular class. So once a class has been defined, what we can do is we can create number of objects belonging to that particular class, right? So this is the way how what we do is we create objects. So once if I have to create an object, then what we need to do is we need to define a class that actually defines the object, and then what we can do is we can create instance from that particular class, which are called as an object. So each object is associated with the data type class with which they are created. So a class thus is a collection of objects of similar type. So this is one of the important statements that you need to understand. A class is a collection of similar objects. So did you see there are different ways in which what you can do is you can define a class. You can define a class as a structure for an object, or you can define a class as a user-defined data type for creating object. You can define class as a template for creating object, or you can define class as a basis for instantiating objects. So just see there are different ways in which you can define a class. Okay, so here what we have is we have example of a class. So class, we have a class car, and we have instantiated 3 different objects from that particular class car, that's called as Audi, Nissan, and Volvo. Okay, so now data encapsulation. Now this is one of the most striking features of object-oriented programming. So data encapsulation is a mechanism for packaging the data and function belonging to an object into a single unit. Okay, right? So it's a mechanism for wrapping the data and function into a single unit. So this is known as encapsulation. So now there might be a question popping in your mind that why do we need to encapsulate? So just see, what we need to do is we need to ensure that the integrity of the data is preserved, right? Or the importance of the data is maintained. So in order to do that, what we do is we do make the data not accessible to the outside world, and only to those function data are accessible that are wrapped inside the same class. That means only the functions that are present in the class have an access to the data that belongs to that particular class, right? So here, by doing this, what we are doing is we are not only preserving the integrity of the data, but we are providing a kind of security to the data as well. So this is one of the striking features of object-oriented programming. So now, as we have said that only the functions that are there defined in a particular class have an access to the data. So what we have now is we have only the functions acting as an interface between the object's data and the program. So interface basically means an interaction medium, right? So now what we have is we have only the functions acting as an interaction medium for having the information about the data object. So whenever a program wants to seek information about the data belonging to a particular object, what it does is it uses the interface that is called as function. Now this insulation of data from direct access by the program is called as data hiding or information hiding. So this is very much important. So what we are trying to do is we are trying to prevent direct access to the data in order to preserve the integrity of the data or provide security to the data, and this mechanism is called information hiding or data hiding. Now what we have in associated with encapsulation are the three different access specifiers. Okay, now these are called as public, private, and protected. So public basically means things are accessible to the outside world. Protected basically means it's accessible to the class, to the members of the class, and to the members of the derived classes, right? Okay, and private basically means it's not accessible to the outside world at all, neither to the derived classes. So public basically means accessible to the outside world. Protected basically means it's accessible to the members of the class and the derived classes, and private basically means it's not accessible to the outside world. Now let us try to understand another important feature of object-oriented programming that's called as data abstraction. Now data abstraction, as you already know, refers to reflecting only the essential features. So data abstraction in case of object-oriented paradigm refers to the act of representing only the essential features while subsiding or not including the background detail or explanation. So here what we do not do is we do not reflect the way how the implementation is being done, but what we try and tend to do is we tend to reflect only now what can be done. So how it is being done is not never reflected, so that's called as abstraction. Okay, right? So now class uses the concept of abstraction and are defined as a list of abstract attributes and functions operates on these attributes. So here what we do is we tend to not reflect the way how the implementation is being done, but we tend to provide information about the way how the or the what will be the values of the attributes and what are the functions, right? So they encapsulate all the essential properties of the objects that are to be created. The attributes are sometimes called as data members, whereas functions are called as methods or member functions. Okay, so this is what is an abstraction: the act of representing only the essential features by not disclosing the unnecessary features. Now, abstraction and encapsulation. Let us try to create a very simple distinction. So, abstraction is a general concept formed by extracting common features from specific examples, or the act of withdrawing or removing something that is unnecessary. Right? Again, encapsulation is a mechanism that binds together code and data it manipulates and keeps both data as well as code safe from the outside interference or misuse. So, you can have abstraction either using interfaces or using abstract class. We'll come to it later in the subsequent chapters. So encapsulation, so you can implement encapsulation using the access specifiers, access modifiers it is called as, so public, private, and protected. Now abstraction solves the problem at design level and encapsulation solves the problem at implementation level. Now why do we need to have abstraction is because, so for an example, if I'm trying to disclose the design of a vehicle to a customer, right? I'm a vehicle manufacturing firm and I want to disclose the design of the vehicle to a manufacturer to the customer. Now whenever I'm disclosing the design of the vehicle to the customer may not be interested with the way how the design is being achieved, but they may be interested with the way how the design looks, right? Now that is what is abstraction. So abstraction basically solves the problem at the design level, whereas encapsulation solves the problem at the implementation level. So here what we're trying to do is we are trying to preserve the way how the data and the code of the belonging to a particular object is being implemented. Okay, so for simplicity, abstraction means hiding implementation using abstract classes and interfaces, whereas encapsulation for simplicity means hiding data using getters and setters. So now what we can do is you can go through the set of advantages of encapsulation and abstraction. This we have already specified in the previous two slides. Now let us move on to next important aspect that is called as inheritance. Now inheritance, as you already know, is the process by which an object or objects of a particular class acquires the property of objects of another classes, right? Okay, so here just see what we can have is we can have different forms of inheritance. So that's why what you can have is you can have an object deriving deriving properties of objects of multiple classes, or maybe single class, right? So it depends on the way how you implement the inheritance process. So inheritance in simple term is the process by which objects of a particular class acquires the property of objects of another classes. Now why do we need to implement inheritance, or why do we need to have inheritance in the first place? Is because you must have seen in case of procedure-oriented programming, what we need to do is we need to implement the functions again and again whenever we want to realize, or whenever we want to, or we have more instances of functions being created every time it has to be used. So now, in order to prevent that, what we do is we use inheritance. So inheritance is one of the important aspects of object-oriented programming, where what we try to do is we try to rely on the concept of reuse. So what do we do is we reuse the existing definitions and create a new definitions out of it, so that what we need not do is we need not implement everything from scratch. So in case of object-oriented programming, inheritance is used in order to promote the idea of reusability. So this means that we can add additional features to the existing class without modifying it, and create a new class out of it, right? Again, now this is possible by deriving a new class from the existing one. So what we can have is we can have a new class that has the properties of the existing classes, as well as it has its own new set of properties. So the new class will have the combined features of the class, as well as its own set of properties. So the real appeal and the power of inheritance mechanism is that it allows the programmer to reuse a class. So this is one of the important aspect of object-oriented programming, where what we are trying to do is we are trying to promote reusability by using existing definitions to create a new definition. Now here what we have is we have very simple example of inheritance. So we have a vehicle base class, from where we have automobile vehicle or pull vehicle being derived. In case of automobile vehicle, we have further classes and buses being derived, and from pull vehicle we have cart and rickshaw being derived. So this is the way how our inheritance works. So in today's class, what we have learned about is we have learned about what are the basic concepts that are there in case of object-oriented programming. Okay, object-oriented programming paradigm. We have discussed what is object, we have discussed what is class, we have discussed in nutshell what is data abstraction encapsulation, and discussed inheritance. So in the next class, what we're going to do is we're going to discuss the rest of the features of object-oriented, or rest of the concepts of object-oriented programming paradigm. Thank you very much.